All right, so here we have our notes for section 7.3, which is multiplying binomials by trinomials. So we looked at multiplying monomials by polynomials in the last section, and that was fairly simple. We're just really distributing that monomial across a polynomial, right? So here we are looking at multiplying binomials. Well, first we're going to look at multiplying binomials by binomials. So a two-term by a two-term, and then towards the end here we'll try some binomials by trinomials, and then there's a geometric application here. So let's look at the notes for multiplying binomials by binomials. So what we do when we're multiplying two binomials together is we call it FOIL. And that's an acronym for first, outer, inner, and last. Okay, so if we look at what this says here, to multiply binomials, distribute each term in the first binomial to each term in the other binomial, then combine like terms. This order of distributing is frequently referred to as the FOIL method. Okay, so we're going to distribute each term in the first binomial to each term in the other binomial. Okay, so let's look at this example here. So what they're doing here is they're looking at just this A first, and they're going to distribute this A across across the second binomial. So the first, the F, the first means the first two terms of each. So the A times the C, and we have AC. And then we look at the outer. The O is for outer, so then the outer terms are the A and the D, so we multiply the A times the D, we get AD. And then we look at the inner terms. For inner, we have the B and the C, they're the two inside terms, so we're going to distribute the B here. And then the last step is the last two terms, which would be the B and the D. Okay, so we do first, then outer. Oops, I did that backwards. Let's see. We do first, then outer, then inner, and then last here. That might have been confusing too. But if you just follow the acronym there, you'll see that each term in the monomial will be distributed. Each term in the first polynomial will be distributed to the second polynomial. Okay, so let's do some practice here. So in example 1, we have x plus 2 times x plus 4. So if we're going to do our first two terms, that would be x and x. We have x squared. Our outer two terms, we have x and 4, which would be positive 4x. Our inner two terms, which would be 2 and x, that would give us positive 2x. And then our last two terms, which would be 2 and 4, which would give us a positive 8. And then it does say, then combine like terms. So we're going to combine this 4x and this 2x together. We get x squared plus 6x plus 8. And that is our final answer. We have multiplied the two binomials together, and this is what they equal. You're pretty much always going to get a, most of the time you'll get a trinomial. And then here, let's look at our first two terms. So we have 2x and x, which gives us 2x squared. I should probably write this a little higher. 2x squared, and then we can look at our outer two, 2x times 5 times negative 5, which is negative 10x. Our inner two, which would be 1 and x, that gives us positive x. And then our last two terms, 1 and negative 5, gives us negative 5. Combine like terms, we get 2x squared minus 9x minus 5. All right. Let's do these practice problems here. So directions say to find each product, answers must be in standard form. So we'll do the multiplying, we'll combine like terms, and then make sure they're in standard form. So first we have a y and a y squared. Our outer two terms are y and 1 plus y. inner 2, 8 and y plus 8y. And then last two, 8 times 1 is 8. Combine like terms, y squared, we get y plus 8y is positive 9y plus 8. This is in standard form with the highest exponent leading, and then that's it. All right, so just make sure when we have these subtractions here that the subtraction symbol goes with the term that follows. So this is, when you're multiplying, we're going to be multiplying by -4 here. So the first two, k squared outer plus 5k, inner 2 minus 4k, and then last two minus 20. Combining like terms, we get k squared plus k minus 20. And that's our final answer there. Number 3, first two, x times x, x squared, outer 2, x times -4, we get -4x, inner 2, -10 times x is -10x, and then last two, -10 times -4 is positive 40. Combine the inner terms here, we have x squared minus 14x plus 40 as our final answer there. Okay, first two terms, x times x is x squared, outer 2, x times -2 is minus 2x. Inner two terms, 2 times x is positive 2x, and last two, 2 times -2 is -4. Combine these, x squared, -2x plus 2x is 0, so these cancel out, and we have x squared minus 4. All right, here, first two, 4x times x is 4x squared. Outer 2, 4x times 3 is positive 12x. Inner 2, -7 times x is -7x. And last two, -7 times 3 is -21. Combine like terms, 4x squared plus 5x minus 21. There we are. All right, number 6. First two, we have 5n squared, outer 2, -4n, inner 2, -5n, and last two, positive 4. Combining like terms, we get 5n squared minus 9n plus 4. These are all in standard form so far. Okay, number 7. First two, we have 9y squared. Outer 2, we have plus 6y. Inner 2, we have plus 3y. And last two, we have plus 2. Let's combine like terms. 9y squared plus 9y plus 2. Final answer there. Okay, first two, we have 12a squared. Outer plus 18a, inner plus 4a, and last plus 6. Combine like terms, 12a squared plus 22a plus 6. That is in standard form. Number 9, 8h times 3h, our first two terms here, 24h squared minus 8h minus 9h plus 3. Combining like terms, 24h squared minus 17h plus 3. It's in standard form. There's our final answer. All right, number 10, first two, 3w times 3w, 9w squared, outer 2 minus 3w, inner 2 plus 3w, last 2 minus 1. Combining like terms, 9w squared, negative 3w plus 3w is equal to 0, so these cancel out and we have -1. Okay, so this one was similar to, number 10 was similar to number 4 that we did, and if you were curious about why, we can look at what we have here. So here we have x plus 2 and x minus 2. Okay, so we have the same first two terms, the same last two terms, but the signs are different. So that means when we get, when we FOIL them out, we're going to have opposite signs of our middle terms. We have a -2x and a positive 2x. So those are going to cancel out to 0. So we're actually just going to be left with two terms, just the first two times the last, and then plus the last two. And then if we look at number 10, it's the same deal. We have the first two are the same, the last two are the same, the signs are opposite, and then they ended up canceling out in the middle here, so we're only left with two terms. So that's just something that you can note. It does come in handy later when we're talking about special products. Okay, so more practice on this page, and then we'll look at binomial times trinomial. So number 11, first two terms, we have 5x squared outer minus 5xy inner plus 4. I'm going to change around the position of the x and the y. I'm just going to put x first and then y. And then the last two minus 4y squared. Okay, this is not, well, let's combine like terms. We have 5x squared plus, oh no, that's going to be minus 1xy minus 4y squared. Is this in standard form? I don't know why I'm asking this as a question, but it is in standard form because x comes before y, so we want to put the x's with the highest exponents first, and then we look at doing the y terms. So this is actually in standard form there. So let's look at number 12. We're starting to get multiple variables here, so everything stays the same. We're just going to add exponents when we have two like variables that we're multiplying together. So first two here, we have 2a squared minus 8ab plus 5ab minus 20b squared. Combining like terms, 2a squared minus 3ab minus 20b squared. That is in standard form, so we'll leave it like that. 13. Oh, look, we have the same first two numbers, the same last two numbers, and opposite signs. So maybe you can guess what this is going to be. I'm going to guess that our middle terms are going to cancel out, just like we just looked at. So first two, we have 4r squared, outer 2 minus 2rs, inner 2 plus 2rs, and last 2 minus s squared. Combining like terms, 4r squared, negative 2rs plus 2rs equals 0, so those are going to cancel out, and we get minus s squared. That is in standard form because r comes before s. And let's move over to 14 here. First two, we get 28c squared, outer 2 minus 8cd, inner 2 plus 7cd, and last 2 minus 2d squared. Combining like terms, we get 28c squared minus 1cd minus 2d squared. This is in standard form because we want the c's first, so that's good. 15. Okay, this is really, really, really important for you to remember, okay, because a lot of students mess up problems like these. When you have something that is being squared, right, we have x plus 4 squared. This is equal to, when you square something, that means that you multiply it by itself. So what this is actually saying is x plus 4 times x plus 4. Okay, and that is how we square a binomial, is we multiply it by itself. So now you can clearly see what the first two are. X squared, outer 2 plus 4x, inner 2 plus 4x, and last 2 plus 16. Combining like terms, we get x squared plus 8x plus 16 there. Alright, number 16, same thing here. So this is equal to p minus 7 times p minus 7. First two, p squared, outer 2 minus 7p, inner 2 minus 7p, last 2 plus 49. We get p squared minus 14p plus 49. Alright, 17. This is another squared binomial, so this is equal to 2m minus 5, 2m minus 5. They're being multiplied together. We get 4m squared minus 10m minus 10m plus 25. 4m squared minus 20m plus 25. It's in standard form, so we're good to go there. And then 18, last one here, a plus 3b squared is equal to a plus 3b times a plus 3b. First two, a squared plus 3ab plus 3ab plus 9b squared. Combining like terms, a squared plus 9ab, plus 6ab plus 6ab plus 9b squared. There is that answer. All right, so we've done a bunch of binomials times binomials. We've had some special products where the middle term cancels out, and then we'd have some binomials that have been squared. So let's look at multiplying a trinomial by a trinomial. Okay, a binomial times a trinomial. So we have 2 terms in the front, 3 terms in the back. So we're not necessarily going to be able to use the FOIL anymore just because there's more than 4 terms. There's 5 terms now. So what we're going to do is we're just going to take this first x and we're going to multiply it by each term in the second polynomial, and then we're going to take the second term, this 4, and multiply it by every term here. Okay, so then we should end up with 6 separate terms, and then we can combine like terms for our final answer. Okay, so first we're looking at x here. We're just gonna pretty much distribute x among the second trinomial here. So x times x squared is x cubed. X times 3x is positive 3x squared. And then x times negative 6 is minus 6x. Okay, then looking at the 4, we're going to multiply the 4 times x squared. That's positive 4x squared. 4 times 3x is positive 12x. And then 4 times negative 6 is negative 24. Let's combine our like terms. We have an x cubed here. We have a positive 3x squared, positive 4x squared, so plus 7x squared. Then we have a negative 6x and a positive 12x, so it's going to be positive 6x minus 24. And this is in standard form because we started with the highest exponent, and so that is our final answer there. Okay, looking at number 20, we'll start with k here. K times k squared is k cubed. K times negative k is negative k squared. K times negative 8 is minus 8k. Then we're looking at a negative 5 here. Negative 5 times k squared is minus 5k squared. Negative 5 times negative k is positive 5k, because the negative times the negative. And then negative 5 times negative 8 is positive 40 here. And then combining like terms, we have k cubed minus k squared minus 5k squared is minus 6k squared. And then negative 8k plus 5k is negative 3k plus 40. And there is that. In our foldable, we're going to look at more examples, different ways to do this, and you can kind of pick which one you like the best. Okay, so 3a here times 5a squared is 15a cubed. 3a times 2a is plus 6a squared. 3a times negative 6 is minus 18a. Then looking at this 1 times 5a plus 5a squared. 1 times 2a plus 2a, and then 1 times negative 6 is going to be minus 6. Here we have 15a cubed plus 11a squared minus 16a minus 6. Already in standard form, there's our final answer. Okay, last one here. Let's look at this 2v first. 2v times 4v squared is 8v cubed. 2v times negative 3v is negative 6v squared. 2v times negative 6 is negative 12v. Then 3 times 4v squared is plus 12v squared. 3 times negative 3v is negative 9v. 3 times negative 6, negative 18. Then we have 8v cubed, negative 6 and positive 12 is positive 6v squared, negative 12, negative 9, negative 21v minus 18. And there is the last example there. Okay, let's look at geometric applications. Okay, so basically what we're going to be doing is we're just going to be multiplying the same thing here. So but it's just going to be assigned to a shape. So let's see what the directions say. Find the area of the shaded region as a simplified expression. Okay, so we're looking at the area of the shaded region and in its most simplified form. Okay, so we have this big rectangle. We want to find the area of this big rectangle and subtract the area of the small rectangle so we can have what's left, which is everything in the shaded region. Okay, so first we'll find the area of the big rectangle. So let's say the area of the shaded region is equal to the area of the big rectangle minus the area of the small rectangle. Okay, so we have, this is a shaded region, this is big rectangle, this is small rectangle. Okay, so the area of the shaded region is equal to the area of the big rectangle is equal to length times width, right? So here is our length and here is our width. So this is equal to 9x minus 2 times 2x plus 7. Okay, our first here, 9x times 2x, excuse me, is equal to 18x squared. The outer 2, 9x times 7, is equal to positive 63x. Our inner 2, negative 2 times 2x is negative 4x, and then the last 2 times negative 2 times 7, minus 14. And then combining these together, we get 18x squared plus 59 x minus 14. Okay, and then let's look at the area of the small region. That's also length times width. We have a length here of, we'll say this is the length and this is the width, so 3x times x plus 12. This is a monomial times a polynomial, so this one's a little bit easier. We have 3x times x plus 12. We're just going to distribute that 3x. We get 3x squared plus 36x. And then we're going to take the area of the big minus the area of the small. So the area of the shaded region is going to be 18x squared plus 59x minus 14, and we're going to subtract this area of the smaller one, which is going to be 3x squared plus 36x. Okay, and now we're just subtracting, which we did in the first section here. So I'm just going to move this guy off here so that we can have enough room to do this. Okay, so first thing we have to do is we can rewrite without parentheses, but we have to distribute this negative among those two terms. So we have 18x squared plus 59x minus 14 minus 3x squared minus 36x. And now we're just combining like terms. We have 18x squared minus 3x squared, so that gives us 15x squared. 59x minus 3x squared, 59x minus 36x, well, that's going to give us 23 plus 23x, and then our only constant is minus 14. And that is our final answer there. It's kind of squished in there. But that is the area of the shaded region. Let's see if we can move this up over here. There we go. All right, so that is lesson 7.3.